Welcome back. This is the next tutorial in the DirectX tutorial series. Last tutorial we set up high performance timing, so we captured delta time, and we also made it so the device would be handled when it was lost. This tutorial is going to be about basically restructuring how we do basically the vertex formats, our structure for vertex. We're going to create a namespace for, and we're also going to create a cube class, which is going to help us render textured cubes. So we're going to go over how to texture a cube. So here we go. So builds, just to see if we're correctly at where we left off. So here we go. We got our FPS going. We got our little Goride cube. So to start, we're gonna move over our vertex format here, the one that we made here. And I'm just gonna cut it for right now. We're gonna move into our utilities and create another namespace called D3D Vertex. I'm just gonna paste that in. So here we have our vertex position color. Now to create a textured cube, what we need to do is we need to actually have a textured vertex, a vertex to hold basically texture locations. So what we're going to do is create another struct, call it vertex, using the same name, name format. We're going to do vertex position texture. And what this is going to have, it's going to have the same stuff, so X, Y, Z, so it's position. And it's also going to have two floats called U and V. Now, if you're familiar with graphics, you'll know this. You'll know what U, V coordinates are. Basically, they're the coordinates for the texture. How it's mapped to different triangles, etc. So what we're going to do is we're going to create our basic default constructor, and then we're going to create our regular constructor. It's going to take float XYZ, and it's going to take not a D3D color anymore. It's going to take a float U and a float V. And again, we're just going to set these equal. And U equals underscore U and V equals underscore V. So there we go. So now we have our vertex position texture. But again, we need one more thing. We forgot the static const dword flexible vertex format. So we need to have that vertex format stored. So now we have that. So next thing though, of course, is this doesn't really exist, but it does. It exists here. So you need to do D3D vertex position color. We set this one. So now what we want to do is we want to set the vertex format for the position texture. Now, what's this one going to be equal to? This one is going to have the XYZ, so it still has that one because it still needs position, but it's also going to have texture 1, so D3D flexible vertex format texture 1. So there we go. So now we have our vertex position texture set up. So I think down here I remember telling you, showing you that the shaded Gorad only has 8 unique verts, while the textured cube would have 24, and that's true. So we're gonna have to remake all of this pretty much to match a textured cube. But before we do that, let's make an actual class. We're gonna make a new item, a header. We're gonna call this Call it whatever you like, but I call mine usually G textured cube. We're going to do some preprocessor directives. If and if basically G text cube H sharp define G text cube H. Now what these are for, they're called preprocessor directives. It just makes sure that there's not like multiple definitions of this class if you include the header file in multiple locations. I call it gtextcube. It's going to have some private stuff. Namely, it's going to have AI direct. First, should probably include the D3D utility, which also, let me check this. Did we do that as well? No, we're going to also have to do that in here. Remember those preprocessed directives? We're going to want to make sure that, that one doesn't have to be there. That D3D util H isn't defined in multiple places. And then do end if. Here we go. So that should be fine. So what is this going to have? Well, what did our cube before have? Our cube had a vertex buffer, an index buffer, a position, a scale, rotation, and position, and a world. So what we're going to do is we're going to create a direct 3D Vertex Buffer 9, call it VB or VBuffer, a direct 3D Index Buffer 9, call it Index Buffer. We're going to have a D3DX vector 3 position, D3DX vector 3 rotation, and of course the D3DX vector 3 scale. So we're going to have position, rotation, scale. We're going to have a D3DX matrix world. So remember, there's the world matrix, which defines how it is oriented in the actual world, and then position, rotation, scale. And that's it for its attributes. Next thing, there's going to be one more. Actually, yeah, there's going to be another one, which is going to be the iDirect3D texture 9. Basically, the texture. Textures are represented by this struct, the Direct3D Texture 9 structure. Next thing is the public. We're going to have the constructor. The G textured cube should take in a D3DX vector 3 for position, a vector 3 for rotation, a vector 3 for scale, and that's about it. Oh no, and a const char pointer. Basically the file name for the texture that we want to actually load. So that's another thing that this should probably need. This should probably need a I don't know, would a string work? Let's try this out. Actually, I'm going to call that texture name. Okay, so which will also mean that we need to include string. So that's that for that constructor. Now the destructor, of course, is just like usual. We never actually really use those. And then for methods, we're gonna have void update, which takes in float delta time. We're going to have a void initialize, which is going to take in an Direct3D device 9 object pointer called device. And finally, a D3DX matrix reference get world, which is going to return the world matrix. And I believe that's all we really need. Actually, wait, that doesn't even have to be public. That's actually going to be down here. We're going to have D3DX matrix. It's not going to return a reference either. It's just going to return itself. Actually, it could return a reference if I wanted to. Let's try it as returning a reference. Then we're going to do void draw, which is also going to take in device. So we have initialize, update, and draw. So let's get to actually programming this. So we're going to create the source file for this. It's going to be a new item, C++ file. We're going to call it the same thing, gtextcube. We're going to include gtextcube header file, and we're just going to get to programming. So we have this, which has that, has the position. So we're going to set those. Position equals position. Rotation equals rotation. Scale equals scale. And then texture name equals file name. Let's see if this actually works. Yeah, it worked apparently. So there we go with that. So then gtextcube, of course that. Yeah. We have void gtextcube initialize, takes in a device. Here's where we're going to initialize it. We have update. We have draw. And finally we have keep doing that. Get world. So there we go. And we're just going to return world for now and see if that actually works. Yeah, there we go. So what we're going to do is we're going to basically figure out what we need. And now that I'm looking at this, we also need to have another thing called basically release, which is going to be called when we destroy the objects, remember, for handling the device. So release is literally just going to destroy. We can do it now. It's going to destroy the index buffer, and it's going to we're going to delete it. Release the vertex buffer, the V buffer. It's also going to release the texture, because remember, texture also needs to be released. So there we go. So we released those. Now, so initialize. Here's the big, the huge amount of code that we're going to have to do. So we already wrote something similar up here, where we had this, where we had our big vertex array, which now errors, but that's okay. So let's do this. Well, first I'm going to, no, I'm not even going to do that now. So let's do this in here. So right up at the top of this, let's create some constants. So constant num verts. So the number of unique verts for this is always going to be 24. Then the num indices is going to be 36 always for a cube. And well, num faces. Nah, we don't have to store that because it can always be calculated. So let's go. Let's figure out what we need to do. In initialize, we're going to first have to create Vertex Buffer, and the way we do this is by using our Vertex Format, position texture, verts, the num verts, which remember is 24. Now what we want to do is we want to do each face individually. So we're going to have to create verts for every face. So the first one, of course, is going to be negative 1.0f, 1.0f, negative 1.0f, 0.0f, and 0.0f. So if I can do this here and show you, basically you have to remember that for these, it's basically, if you're doing cube, it's 0, 0, then over would be 0, 1, and then down would be, so you just keep having a bunch of these. So you'd go down a bit. This would be 0, 1, and you'd go over, and this would be 1, 1. So if you can visualize it for each face, so this is one face, and then the other face, and we have to keep doing that. So these are the UV coordinates. So for this very first point, it's 0, 0. Then for the next point, so point 2, it would be 1.0f, 1.0f, 1.0, negative 1.0f, 1.0f, 0.0f. The nice part of these, though, I'm doing it for each face individually. It's easier to figure out how to render them in clockwise order, as you'll see. So just follow along. If you know how to do this, then you can skip ahead. But 1.0f, negative 0.0f, negative 1.0f, 1.0f, 1.0f. So there we go. We're done with that face. Now let's do the back face. The back face, I want to do. What I want to do first. I want to do 1.0f, 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 0.0f, 0.0f. Then I want to do negative 1.0f, 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 0.0f, D3D vertex, vertex position texture. Then I want to go for the next one, for the third one, I want to go back, but then go down. And this would be 0.0f and then 1.0f, so it's in the Y. And then finally, for the last one, I want to go negative, negative, positive, 1 and 1. That's the back face. So now left face. D3D vertex, vertex position texture. we have, for the left one, we want to go, for the first thing, we want to go back all the way. Then we want to go, again, stay there, but we want to go forward. Vertex position texture. Again, we're still going to be like this, but we're going to be down low, and we're going to be in. So this is going to be 0.0f, and then finally it's basically just down and then in. So for the last one. So now we're going to do the right face. It's a very long and tedious process, as you can tell. Now these are all to the right in a left-handed coordinate system. So for this first one, we're going to want it to be basically here, closest to us. Vertex position texture, we're going to want, again, 1.0f, 1.0f, positive. Go down again a bit, scroll down so you can see. 1.0f, negative 1.0f, negative 1.0f, 0.0f, 1.0f. Negative, positive, finally, that's that. So, now we're just doing the top face and the bottom. So we're almost done with this. So yeah, so the top would be, we want to go back. We want to go over, top, over. We want to go back. Still on top. Then for the final one, we want to go over, okay, so finally the bottom face. Finally the bottom face. So the bottom face should be basically, I think about this, yeah, I want to do it that way. So it's going to be positive, negative, positive. Now I'm declaring these all in clockwise order basically, so that it's going to be easy to write the adjacent index buffer. So I want to go over, stay there, 1.0, 0.0. So you're going to see that it follows a pretty easy pattern pretty soon. Oh, I think I already kind of screwed that up. So there. No, this one's still fine. It needs to go back, but it needs to be negative. Yeah. Negative, and then this would be 0.0. Yeah, that would be 0.0, 1.0. Got a little brain fart there for a second. That would be negative, 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 1.0f, 1.0f. There we go, so we're done with that. Now what we should be able to do is create the vertex buffer. So what we do is we do device create vertex buffer. So the length would be, if we look, how did that work again? So yeah, it would be the number of vertices, unique vertices, times the size of our actual structure. So yeah, so it would be numverts times size of d3d vertex position texture usage. I don't even think we really used anything for the usage. Yeah, it was just null. We use d3d vertex position texture flexible vertex format, d3d pool managed. We always want to use the managed. We want to reference the our v buffer stored in there, and for the final shared handle we just set null. So there we go. So that should be created, the vertex buffer. Now remember, we need to lock it and then set it. So what we're going to do is we're going to go we're going to create that void pointer pverts. We're going to do memcopy safe. Destination is pverts, size of verts, pass in verts, size of verts again. The reason we're using memcopy safe is because the other one had some security problems. Regular memcopy. Of course, though, we need to actually lock the buffer first, so I forgot to do that. So we need to lock 0, size to lock, size of verts. I believe we locked it to size of verts, and yeah, and then we passed in the pointer to the actual vert data. So passed in void pointer. Oh, doing that. Void pointer to a reference to pverts. Set 0 for the flags. Then we copy all that in, and then we unlock the buffer. So there we go. So now we want to set up the index buffer. So again, we're going to create our indices array. It's going to have the num indices, which remember is 36 for a cube. That's 36 indices. 3 for each triangle. And what we're going to do is we're going to do the front face, which should be 0, 1, 2, 2, 1, 3. If we created this correctly, should go 0, 1, 2, and then 2, 1, 3. And that should essentially work all the way down. So we did the back face next. So back face should be 4, 5, 6, 6, 5, 7. Next we did the right face, or no, the left face. Which should be 8, 9, 10, 10, 9, 11. Right face should be 12, 13, 14, 14, 13, 15. The top face should be 16, 17, 18, 18, 17, 19. The bottom, excuse me, the bottom should be 20, 21, 22, 22, 21, 20, 3. That should be correct. We should have ended with 23. Having used every every vertex. So now we need to do the same thing. We need to go and do device, create create index buffer, num indices times size of word, and now for the usage, we had write only, index 16 managed, of course. So write only d3d index d3d format index 16 d3d pool managed and I buffer and then null. So we want to do a void pointer p indices. I'm going to do I buffer block 0 size of indices void pointer to reference to p indices 0. So here we go. So we want to do memcopy safe into p indices size of indices and then we want to unlock. So there we go. So we created both the vertex buffer and index buffer for this. So that should be pretty good. So what we want to do now is we want to actually load our texture. So we should have a file name or file path from our constructor. So all we need to do is use a method called create texture from file. What this will do is it takes in the device, it takes in the string, so it would be text name dot cstring, and then finally it would take in the reference to our texture, and then we can just check to see if that actually succeeded. If that's null, we can display a message box. So failed to create texture. Then we just return. So there we go. That should be it for our initialize. So our update, really we don't need to do anything in right now. Our world we'll get to in a second. So our draw, here's where it gets kind of interesting. So first, we know that we need to we're going to need to set the world or set transform. So d3d transform world, and we need to use get world. And yeah, so that's not going to work. In order to do that, I'm just going to make this normal. I think I probably could have returned, but let's just make that a reference. Here we go. So we want to set the transform, and then we want to set vertex buffer, right? No, wait. Oh, set stream source. Sorry, now I remember. 0 and vbuffer 0, and stride would be size of, I believe it's the size of the actual vertex. position, right? Yeah, size of vertex. So in our case would be size of D3D vertex, vertex position texture. That doesn't actually have to be a reference because it already is. It's a pointer. Device. We set the stream source. We want to set the indices to our I buffer. Again, it doesn't have to be like that. Okay, so we set that. We also want to set the FBF to D3D vertex, vertex position texture, FBF. What else do we want to do? Yeah, we basically just want to draw. So I'm going to draw index primitive, D3D PT triangle list. Like always, 0 for the base, 0 for the min. Number of vertices is numverts. Actually, no, that would be num indices. Num indices, 0. So this technically 36 verts. Primitive count would be num indices divided by 3. So really 12 in the case of a cube. But here's one more thing that you need to do actually. Because now we're using a texture, you need to go set texture 0 and then pass in texture. So we did set the actual texture that we're using to render with. And that should be good. I think that's all we needed. Set indices, set stream source, set world. There we go. So yeah, so world. Here's where we need to do some stuff. We need to create some matrices. So we're going to create the scale, the rotation X, rotation Y, rotation Z, and translation. So basically, we're just going to do create scaling. Oh. We're going to pass in our scale and scale.x, scale.y, scale.z, rotation x, rx, and we're just going to pass in rotation.x and do the same for all the other ones. So rotation y, z, rotation.z, and finally D3D X matrix translation, translate. We're going to pass in position.x, position.y, position.z. And what we're going to do is return world times scale times rx times ry times rz times translate. So there we go. That should be fine. Now of course those errors are from all of the code in here. So what I'm going to do actually, now that we don't really need this, you can keep it if you want, but I'm actually going to delete it because I don't necessarily need any of it. So now we shouldn't see pretty much anything. Well, there's still this drawing. So we're not going to need any of this. So there we go. So now we have our blank screen again. So what we're going to do in here is we're going to add a GTextured cube pointer object called cube. We're going to add the include. So I'm just going to refactor, quickly add the include. So here it's added up here. And we're going to do in here we're going to set cube equal to new GTextured cube. This takes a D3DX vector 3 position, so we're going to position this at 5 units into the world. I'm going to position it with zero rotation for everything, and for its scale, I'm just going to have it scaled uniformly. And what it should be I'm going to call it dirt.png, and what I'll do is in here, what you need to do is you need to copy a image into there. So I have conveniently right here I have this dirt texture. I'm just going to copy and paste that in here into the top level. So now I have a dirt. So dirt.png. So there we go. So that's being created. So we have our cube being created. I'll line these up a bit so it's easier to view. There we go. So now what we want to do is in here, I'm just going to go and initialize with our device. In here, I'm going to call release on the cube. And I'm going to, in here, call render. Or draw, rather. And before we do anything, I want to do one more thing and go in here, and I want to increment the rotation.x, or actually y, plus equal delta time. So we'll see it actually spin, or we should. But rather, we didn't get anything. It's interesting. Well, first off, I'm going to call update in here for a second. Cube update. That's in delta time. So as you can see, it's there. However, clearly our texture's coordinates are quite off. So let me check that. So let's figure out what's causing this problem. Not in here, I doubt it. By the way, we can also get rid of all this, because we don't actually need that. We don't need these. So, and we don't need that, because that sets the render state to Gorad, which we don't really care about. Let's go in here and see if anything's wrong. If I scan over, let's try this. See what happens now. There you go. So that was it. Basically, the world matrix wasn't being created correctly. That's why it was distorted. So here you go. So now you're looking at a textured cube. So I have my dirt texture running on it. Doesn't really matter what texture you put in there. Let's see if, so all the side faces are rendering correctly. Let's change this to the X value, and let's pitch it. So do a rotation in the pitch direction. So there you go. All of the faces have correct textures. So now let me do a nice rotation in all directions. So there you go. So here's the nice textured cube rendering conveniently. So that's pretty much it for this tutorial. The next tutorial I'm going to cover lighting and fonts. So there you go. You have a textured cube. I hope you enjoyed the tutorial. More should come shortly.